Hi, my name is Brittany Ackerland, and I'm doing my first video presentation here. Question number 1 is about Piaget's implications. So to answer that question, I thought I'd give a brief summary of Piaget's theory of cognitive development, which begins with 4 stages. First stage is sensory motor stage, followed by pre-operational, concrete, and finally a formal operational stage. So Piaget believes that we as humans all go through this universal development where our cognitive abilities are transitioning and growing as we experience things in our outside environment. And so the implications of this are that as teachers, we need to recognize what stage our students are in, because they only have the ability to understand things that we are teaching them in a method that coincides then with their cognitive development stage that they're in. We'll move on to question 2. Define cognitive incommensurability with an example from the classroom. So cognitive incommensurability is the mismatch. It kind of then just follows onto why it's so important to recognize what cognitive stage our students are in, because there is this incommensurability, which is a mismatch of teaching in a stage that your students aren't quite in yet. So there's a gap between it. And us as adults, we are in our formal operational stage. So we're in our higher form of cognitive development. And so our methods of understanding things and possibly conveying things are going to be at a higher level than if we're teaching, than the level that students are at. If we're teaching, middle school students that are going to be in your concrete operational stage, they're not going to understand some of the abstract ideas that we as adults can understand. So we really need to figure out ways to convey our knowledge to the students in ways that they can understand. So an example of the incommensurability that could happen in the classroom is, say, you have a teacher that, say you have a middle school teacher trying to teach algebra or trigonometry. I don't want to use algebra, or thermodynamics, say, in science, where there are abstract ideas of using symbols for mathematics, or the idea of energy transfer. You don't see energy. That's an abstract thought. You have to just know that it's there. Or measure heat transfer. You don't see heat and how it transfers. So that's an abstract thought, and it's an idea that you have to process. And students that are in a concrete phase, middle school or younger, they are really going to have a hard time understanding that to a level. So you can possibly teach it, maybe have some models or some experiments, like such as maybe like melting an ice cube on a desk. You can then see and explain that there's heat transfer going on between the desk that melts the ice cube, but it's recognizing that gap as the teacher and the students that are going to help you develop those teaching methods to your students, so that they can understand what it is you're trying to teach them. So next question is define dual epistemology. So dual epistemology, as we've learned, is the idea that there are 2 types of knowledge. There's concrete knowledge and abstract knowledge. Concrete knowledge is just blatant facts. The capital of Illinois is Springfield. Our first president of the United States was George Washington. They're facts that really aren't arguable. And there's really no other means of getting to the answer. The answer is what it is. Abstract knowledge is more a knowledge that possibly has multiple means of finding or getting to that same answer. It's ideas, concepts, thoughts. So it generally is perceived differently by different students. So an example, I guess, of an abstract knowledge that I kind of jotted down here was the fact that scientists now are debating how many planets there are. Well, why would they debate how many planets there are? It's questions of what constitute a planet anymore. We're not denying that these structures are there in the universe, but how are we going to now categorize them? So that is abstract knowledge, abstract thinking, and that's the difference between the fact there is planets, that's concrete, or there is those structures, there's structures, but that's concrete. What are planets? That's more abstract. Question 4 is explain the cognitive process of a person's conceptual learning. So the actual process of conceptual learning includes a state of disequilibrium in the beginning, where we are first taking in this new idea. It doesn't flow with our formulated schema at the time. There's these ideas of schemas, is how we perceive the world, is in this schema of all of our different thoughts and learning experiences have formulated into how we perceive things, and kind of like our aura of who we are at the moment. When we learn something new, we are assimilating that information. So we're starting to get new information. Our brains are in a state of disequilibrium because they don't quite understand that. It doesn't quite fit. So we're learning it, assimilating it, and then we move to, once we start to understand, we move to the accommodation process, where we are kind of reforming our schemas to incorporate this new information. And as we get better at something, maybe a new skill or new information, we reform our schemas, and then our brains return back to that equilibrium, and we are comfortable again. When we now have a new outlook, we're in kind of say a new person, a new we've got new knowledge, new skills, and then altogether we're balanced once again until we get through this cyclical cycle again, where the next day we're learning something new. It's always good to learn something new every day. Question number 5 is the mastermind game and how it applies to constructivism, why it is not direct teaching or nativist teaching. So the mastermind game kind of reminded me of Wordle, but a little harder. So it applies to the ideas of constructivism because the code maker was guiding us through the process of breaking the code. So constructivism is the idea that the student is going to have these experiences somewhat independently, but you have a teacher that is guiding them and kind of leading them in the direction. They're providing the right environment for them to succeed in their lust for gaining knowledge or growth. So the code maker was kind of the teacher or the guider, as every time you enter a code, they pop back out some suggestions or clues as to whether you're right or wrong, and just keeping you on that path towards the answer. So that goes along the lines of constructivist teaching. If it was direct teaching, it would be more like, here's the code, memorize it. That's bam, that's what it is, just very direct. It's a fact to memorize. That code gets you in this door. This code B gets you in B door. That would be more direct teaching. Nativist teaching would be possibly the same game, but with no feedback from the code maker. It would be just guesses, just blind guesses the whole time. You're on your own, no guidance, no feedback. Yeah, that's the differences between that and that game. Question B, teaching methods that qualitatively enrich students. So I did have to take a little bit of time because I'm not teaching yet. So I'm still learning my different teaching methods and what styles I like and will work for me. I've really appreciated the information that I'm getting from this class and from my other class right now, reading and content areas. So I kind of drew a little bit from the strategies that I'm learning there to answer this question. So for pre-operational stage children, I was thinking that teaching them to read or teaching them to form mental images in their head while they're reading is a good teaching strategy. It gets them thinking about what they are reading, kind of deepens their thought process, keeps them more engaged. And then afterwards, you can actually have them draw out what those pictures were, and that could possibly create that disequilibrium for them, especially if we're reading a story where possibly there was vocabulary that they didn't quite understand, but now they have to write it out to form a representation of it on paper. So that would possibly be a struggle where the teacher could then step in and help guide them through that by, well, what don't you understand? What words do you maybe need to look those words up? That will help you form this image of what was happening there and represent the events that were occurring in the story. So yeah, teaching them to form mental images while reading, I think, is a good method to teach qualitatively, to form a deeper thought process while taking in information reading. And then for older students, just an easy one, I guess, was to encourage qualitative learning by collaborating in groups with peers. It's just a natural way for students to get other perspectives from people that don't think like them. They can argue, so they have to form reasons for their perspective and convey those reasons to their peers, and all of that would create a disequilibrium as well for them, trying to understand other perspectives and also conveying their reasons for their own perspective to try and convince someone why they are correct. So that would form that disequilibrium in their head, which, as we know, is the beginning of cognitive learning, which is a qualitative aspect of our development, our cognitive development. So yeah, I think I ran through those a little bit quick, but I hope that's all right. And yeah, thank you.